Okay, if you look at this example, you'll notice, of course, that we've got three equations, and each of those three equations has three different variables in it. They each have x, y, and z. And so we are going to solve this system of equations using elimination. So first thing we want to do is pick a couple of equations and pick a variable to eliminate. Now there's usually some choice here. Well, I should restate that. There's always choice. Sometimes, however, one variable or a couple of equations might look easier than the others. I'm going to start in this first example by realizing that I'm very close to being able to eliminate my z's. If I look at these first two equations, they both have a plus z in them. And so if one of them was just minus z instead of plus z, then I would have the opposites that I need to eliminate. So what I'm going to do is I'm going to take this first equation and I'm going to multiply the whole thing by -1. That's essentially, just going to change my signs, and it will give me the opposite z's that I need to eliminate. So my new equation is going to say -2x plus 3y, because I'm multiplying by a -1, minus z equals 0. And so now, since we have that minus z, we can eliminate with z plus z that we had in the second equation. So I'm going to go ahead at this point and just bring this second equation over so I can see both equations one on top of the other. Okay, so now if I add these two equations together, for my x's, I get positive 2x when I add. For my y's, I get plus 5y. My z's are eliminated, and we knew that was going to happen, and it's equal to 20. So now, since I eliminated the z, I need to do that again with a different combination of equations. So this right here is for equations 1 and 2. I'm going to eliminate z again using equations 1 and 3, but I'm going to use that new equation that I created for the first one when I multiply by that -1, since that's the equation that has the minus z in it. So I'm reusing this one here. So I'm going to bring that over. It's minus 2x plus 3y minus z equals 0. And then this last equation in the original problem, just x plus y plus z equals 3. I'm going to use that as well. So when I add these equations together, -2x plus x makes -1x. 3y and y makes 4y. My z's are eliminated, and it's equal to 3. Okay, and a little note here, this is when I use the first equation and the third equation. Okay, so now what I have here is I've got two equations that are down to just x and y, which is what we want because that makes it easier to continue eliminating. So if I look at these two equations, I can see that it's going to be fairly easy to eliminate my x's. I would just need to take this equation here and multiply it by 2 so that we end up with a -2x right there. So I'm going to go ahead and bring this equation with, because we're going to use that one just the way it is. 2x plus 5y equals 20. And then this equation here, I'm multiplying that entire thing by 2. So what we have is -2x plus 8y equals 6. And I'm just making a note here to try and kind of keep track of the work that I've done. So then I have the opposite x's that I'm going to need, and that will help me to eliminate. So when I add together my x's eliminate, I've got 13y, and it equals 26. So that just means that y is 2 when I divide both sides by 13. So at this point, we've got 1 out of the 3 parts of our answer. And just like in regular elimination, now it's a bunch of substitution to use what we already know to find what's missing. So what I'm going to do is use this y equals 2, and I'm going to substitute it in to this equation right here. Okay, it really doesn't matter where you substitute as long as you're picking one of the equations that's down to 2 variables. So if I use this equation here, I'm going to put in y equals 2, and that means I'll be using it to find x. So here's the equation I'm working with. And then here's me putting in 2 for y. Okay, so we get 2x plus 10 equals 20, which means 2x equals 10, so x is 5. And just like that, that was pretty simple once I realized what I should do. It's pretty simple to find the second part of my answer. And now we just have one more thing to find, and we need to find z. So I'm going to be looking back at the original 3 equations that I started with, since I'm factoring in all 3 variables at this point. I'm going to put in what I know for x, what I know for y, and I'm going to use that to find z. So that third equation that we started the problem with is definitely the easy choice right here. So I'll put in 5 for x, 2 for y, and I will use that to find z. So right here I've got 7. So when I subtract 7 on both sides, I get z equals -4. So in terms of final answer, you want to make sure you write this as an ordered triple. And you always put your ordered triple in the order of x, y, z. So in this case, my answer is 5, 2, -4. That's where these 3 lines, or these 3, I guess they're actually not lines, they're planes. That's where these 3 planes would intersect on a 3-dimensional graph. Okay. Let's move on to a second example. All right, so once again, I've got 3 equations, and each of my equations has 3 variables at play. And you kind of want to look at the equations and strategize in terms of what might be easiest to eliminate. So what I'm going to do this time around is I'm going to realize that there's a positive 2z right here. So if I could just make this be a minus 2z, then that would be easy to eliminate. So I'm going to multiply the entire second equation by 2. Now, before I do that, I'm just trying to make sure I stay organized. I'm going to go ahead and write down this first equation just the way it is, since I know I'm going to be using that. Okay. So then this second equation I'm multiplying by 2. So what I really have is 4x plus 2y minus 2z equals 10. And so there you can see that we have the opposites that we need. So I'm going to go ahead and add my 2 equations together. That will give me 9x plus 5y equals 12 because my z's have been eliminated. And I'm just making a note right here that that was equation 1 and 2. It just kind of is helpful if I'm trying to look back at my work and see what I've done. Now I'm going to choose to use equation 1 and equation 3. And what I'm going to do is just multiply this entire third equation by -1, because that will change this to a minus 2z, and I'll be good to go. So I'm going to start once again just by kind of rewriting the very first equation, because I'm using it and I'm not changing it. And then now I'm ready to multiply this third equation by -1, which is essentially just going to change all my signs. So it's going to be -x minus 4y minus 2z equals -16. And now I can add my two equations together. So 5x and -x makes 4x. 3y plus -4y makes -1y. My z's have canceled and eliminated, and it's equal to -14. So now I'm going to use these two equations that I've created here, and it looks like it's going to be easy to eliminate the y, because I can just take this second equation down here and multiply it all by 5, and that will give me the opposite y's that I need. So I'm going to kind of bring this with here, because I'm going to use that just the way it is. I'm going to multiply this entire equation by 5, because that's going to create the opposite y's that I'm looking for. So when I multiply that whole thing by 5, I end up with 20x minus 5y equals -70. Okay, so adding these two together now, I end up with 29x equals -58, and that's because my y's have been eliminated, which means x is -2. So I'm 1/3 of my way there to the answer. And before we move on, I guess remember this was equation 1 and 3 that we were working with back here when we did this step. So I'm going to use this x equals -2 to find out what y is, and I think I'm going to plug it into this equation right here. So I'm using the equation 9x plus 5y equals 12. I'm putting in x equals -2. So 9 times -2 plus 5y equals 12. So that's a -18 right there, which means I'm going to add 18 to get rid of it. So 5y equals 30, and therefore to finish it out, y is 6. Okay, so we've got 2 out of our 3 answers, and now we just need to use x and y to find out what z is. So at this point, you're going to want to go back to one of your original equations that you started with, since you're having to use all 3 variables now. And I'm going to use the third equation. So I'm using the equation x plus 4y plus 2z equals 16. Okay, so put in -2 for x and put in 6 for y. And we're going to use that information to solve for z. Okay, sorry, got distracted by the dinging on my phone. Alright, so what we have here is -2 and then positive 24 plus 2z equals 16. So that's 22, and I guess you don't really have to write those 2 steps out as separate things. It would be fine to just do it all together at once. So then subtract the 22 on both sides and get 2z equals -6. So that means z is -3. Okay, So then putting it all together, write this up as an ordered triple. X comes first, which is -2, then y, which is 6, and we end with z, which is -3. All right, moving on to example 3. Same as before, we've got 3 equations with 3 variables. So we're just going to do a whole bunch of elimination. And then once we've done that a couple of times, we'll start substituting things back in. So if I look at these equations here, I'm going to start out by using the first equation and the third equation. And I am going to eliminate my x's, and the way I'm going to do that is I'm going to multiply this third equation by a -2. So let me just rewrite this one the way it is, since we're going to use that without changing it. Now here, when we multiply this whole equation by -2, we're going to get -2x plus 10y plus 4z equals 8. And so we have the opposite x's that we were looking for. So those are going to be eliminated, and we have 13y plus 8z equals 10. And just a note to self here, this was for equations 1 and 3. Okay, now what I'm going to do is I'm going to use equation 2 and equation 3, and I'm going to eliminate my x's once again. I want to make sure I eliminate the same thing here, but that's going to require me to multiply in a little bit of a different way. I want, if this is a positive 5x, this time I want to multiply this last equation by a -5, so that will allow me to eliminate. So I'm going to go ahead and rewrite this second equation since it's not changing, and we're using it just the way it is. And now this third equation is going to get multiplied by -5. So -5x, I'm multiplying right here by -5, plus 25y plus 10z equals 20. Okay, so I have the opposite that I want. That's going to eliminate my x's. And right here I'm going to have a positive 23y plus 13z equals 20. Okay. Now, unfortunately this time I'm going to keep working with these two equations here, and it's not quite as nice and neat in terms of multiplying and getting your opposites, but I think it's going to be easiest to create opposite z's, and the way I'm going to do that is to turn them into 104z and -104z, just because that keeps things a little bit smaller than the other option. And if you don't mind working with, decimals and messy numbers, you can find something else to multiply by. But what I'm going to do is I'm just going to multiply this first equation by 13, and then I'm going to multiply down here by -8. So if I multiply this entire equation right here by 13, I get 169y plus 104z equals 130. Now if I multiply this entire equation by -8, what I end up with is negative 184y minus 104z, so those are the opposites, and it equals negative 160. So again, not as nice and neat as the other examples just because we had to multiply by fairly large numbers here to create opposites. So when I add these together, when I add my y's, I get negative 15y. My z's are eliminated, and I get negative 30 over here when I add 130 and negative 160. So even though it was kind of crazy there for a second, it works out nice and neat, and we get y equals 2 for this part of our answer. So if we know y equals 2, then let's use that to our advantage to figure out what z is. So I'm going to use y equals 2, and I'm going to put it in right here and use that to solve for z. So I'm going to write down the equation that I'm using just to stay organized. And now again, I'm putting in y equals 2. So 13 times 2 and then plus 8z equals 10. So 13 times 2 is 26. So I'm going to subtract 26 on both sides and get 8z equals negative 16. So z is negative 2. Okay, so I've got 2 out of the 3 parts of my answer, and I will now use that to go find what I'm missing, which is x. And so I'm going to use this first equation here from the original problem, put in 2 for y, put in negative 2 for z, and solve for x. So I'm using this equation here. X is what I'm looking for. Put in 2 for my y, negative 2 for my z. So I get x minus 10 plus 4 equals negative 4. Simplifying right here, that's really just negative 6. Which means if I add 6 to both sides, I get x equals 2. So final answer to put it all together as an ordered triple is 2 for x, 2 for y, negative 2 for z. Just labeling my work here. Okay, we're going to end with an example that's just a little bit different. And it's actually different in a good way. Because what I have right here is I have 3 equations, but the third equation actually only has 2 of the variables, which ends up making things a little bit simpler. Because it basically cuts out one of our elimination steps. So since this equation right here does not have a z, oh, man, I have a typo right here. That, I'm sorry, should be a z. So it's x, y, z, just like all the rest. Okay, anyway, since this equation, this third equation, does not have a z, then that's what I want to eliminate in the other ones. And thankfully, that works out very nicely right here, because I'm just realizing that I wrote this whole problem down wrong. It could end up working out okay. I'm just not sure. It could end up being really messy numbers. Okay, I'm going to go ahead and try it. I have opposite z's right here. which is really nice because I don't have to multiply by anything to eliminate them. So I'm just rewriting both of these. So that I can show my work clearly. Okay, so when I add those two equations together, I get negative 10x, positive 8y. My z's are eliminated. And then I get negative 34 right here. Okay, so these two equations are already down to just x and y. So again, the fact that this third equation only had two variables to begin with ends up saving us some time. So I'm going to use these two equations and I'm going to eliminate one of the variables. And if I look here, I think it's easiest to eliminate the y's. And I'll do that by turning one of them into a positive 24y and one of them into a negative 24y. So right here, if I multiply by positive 4, I'm going to get negative 24x plus 24y equals negative 48. And then I now need to turn this into a negative 24y. And I'm going to do that by multiplying everything by negative 3. So I'm going to get positive 30x, negative 24y, and positive 102. So I have the opposites that I need. If I do negative 24x plus 30x, I get 6x. My y's have eliminated. And then I get 54 if I do negative 48 and 102, which ends up working out nicely. It means x equals 9. So we're part of the way to our answer now. And we're going to see what happens after this. Like I said, I wrote the problem down completely wrong, so it could end up getting messy. Okay, so we're going to use this x equals 9, and we're going to use it to figure out what y is. So I'm going to use this equation here, but we could use any of the equations that just have the x and the y. So I'm putting in 9 right there. So I get negative 90 plus 8y equals negative 34. So then I'm going to add 90 to both sides and get 8y equals 56. And that means y equals 7. All right, one variable left to go. We need to figure out what z is. So I will take x and y, and I'll put them in to find z. You can use either one of these equations. It doesn't matter which one. So if I use the first one, I'll put in 9 for x, put in 7 for y, and I'm solving for z. So when I do my negative 5 times 9, I get negative 45 right there, and then positive 35 right here. So negative 45 and positive 35, that's just negative 10. So then I'm going to add 10 to both sides. And get 3z equals negative 13. And so it does not come out to be a perfectly nice, neat answer. However, considering the fact that I'm totally winging this and, like I said, wrote the problem down wrong, that is pretty darn good. So final answer to put it all together into an ordered triple would be 9 for x, 7 for y, and then negative 4 and 1/3 for z. And so the point of this last example, even though I kind of messed it up, the point of this last example was to show you that every now and then you get lucky in terms of the problem and how it's set up. And if you don't actually have all three variables in all three equations, it typically makes your life easier. You just kind of have to recognize that before you get started and use that as part of your strategy. So just be on the lookout for that. Now, the one thing that I haven't mentioned here, and we're not going to take time to do an example of it, but the one thing I haven't mentioned is the possibility of no solution and infinite solution. And the thing you want to remember there is just that if you ever are solving and you come across something that's impossible, so side note, if you're solving and you come across something that's impossible, like, 10 equals 17, as long as you're sure you didn't make a mistake somewhere, you can go ahead and stop and be done and say there's no solution. Okay, again, because that's not possible. If ever you are solving and you come across something that's like always a true statement, for example, like 5 equals itself, 5 equals 5, again, double check that you didn't make a mistake, but as long as you're sure you've done everything correctly,